In the previous video, I have discussed about how does a clipper circuit work, and in this video, so let us just consider one problem and we'll to try to solve that. So the problem is determine V0 for the input shown using the given clipper circuit. Okay, so what is the question given? So first let us do that. So in the question it will be given there is a signal and the values are like this. Okay, so it goes like this and so on, and here it is given this value is 20 volt and this value is your minus 5 volt. Then again this point is 0 and this point is t by 2, this point is t, and the diode circuit is given as, so here the diode circuit is given. So here the input is given and here we are measuring the output V0 and the resistance value is given 2.2 ohms. The question is to find the V0 for this particular circuit. So for that what you can do, so first we have to analyze this diode circuit in two halves. One is the positive half or the 0 to t by 2, another half is the negative half. Okay, so for the positive half, that means I can write from 0 to t by 2. Okay, so from 0 to t by 2 what will happen? So positive voltage will be applied here. So positive voltage, and how much? This value is 20 volt. So once this is positive voltage is applied here, so what will be happening to the diode? Now for the diode, this is positive, this is negative. So you can see from the input, positive side is connected to positive, negative side is connected to negative, and the diode will be forward bias in this case. So if the diode is forward bias, so what we can do, we can represent the diode as a short circuited point in the circuit. Okay, so this is my V0 I am going to measure here, and this value is 2.2 ohms, and we are applying a voltage positive terminal here, negative terminal here, and the value is 20 volt. Now clearly you can see here, because this is a short circuited, so all this 20 volt, or what will happen, all this 20 volt will be dissipating across this resistor. So this value 2.2 ohm is really not of any use, but as we know, if I apply KVL, so how I can apply, current will be flowing in this direction. So I will take 20 volt minus, if I take the current value is I, so I, and this is R, so that means I can write I into R is equals to 0. That implies I into R is equals to 20 volt. So this is nothing my V0, because I am measuring my voltage at this point as positive terminal here, negative here, and for the resistor also voltage drop will be in the same direction. So my voltage output here in this case will be 20 volt. Okay, now we'll consider for the second part. So second part is for t by 2 till t. So you can see here for t by 2, for t by 2 from this point to this point, the voltage is minus 5 volt. Okay, that means, so positive terminal is here, negative terminal will be here, because it is now in the reverse condition. So now what will happen to this diode? Diode is here open circuit, because negative is connected to positive side and positive part is connected to negative side. So what has happened before, we don't need to bother about that. So what has happened, that has happened, and the voltage here is 5 volt, right? So 5 volt we are applying here, right? So we'll be drawing the circuit for that as well. So here in this case the diode will be open circuited because of reverse bias, and the load resistance is here 2.2, and we are measuring our voltage plus minus here, that is my V0, and we are applying a voltage or applying a potential where this is negative, this is positive, and we are getting 5 volt here. Okay, so now what will happen, the current will be flowing in this direction, right? So that means 5 minus I into R is equals to 0. Okay, whatever resistance value is given, that doesn't matter here. So 5 minus I into R is 0. So what is this? Now is this equation correct? So this equation won't be correct. Why? Because there is a open circuit, even if I draw the current direction like this, it will not reach the end point. That means no current is flowing here. Okay, so don't write the KVL as this one because no current is flowing. So what will happen? The potential here will be 0. In this case, the output voltage value is equals to 0. Okay, that means for this period t by 2 to t, the second half or the negative half of the input, the output value is 0 here. Okay, now how to draw the waveform? So let us see that. To draw the waveform, what I can do, I can draw the waveform here and then I will extend that. Sorry. So this is my 20 volt, 5 volt and again 20 volt again like this. So this is 20 and this is your minus 5. I'll draw one more line to represent the output. So this is my input line and this will be my output line. So what we got? For the positive part, we are getting the voltage value as 20 volt. So positive part means up to here, this point. So up to this point, we are getting the voltage value as 20 volt. Okay, now it reaches this point where we start the negative part, and in the negative part we know we are getting the voltage value as 0. So that's why the voltage value will be 0, and once again here when the positive cycle comes, then it will again store it will show the 20 voltage again, right? So that means finally we are getting a waveform which looks like this, and we are crossing out the negative part. So this is how the output waveform will look like. And in the previous video I have told why it was called as a your positive clipper, and here it is a negative clipper. Why it is negative clipper? As you can see here, it is clipping out the negative part of the input signal. Okay, so this is where we are considering a ideal diode, where we are considering the potential values is 0. As soon as positive voltage is there, it will start to conduct. So next we will see with sinusoidal wave and a practical diode. So in the next video, we'll be discussing about that. Thank you.